Okay, this is our update for November. We're getting closer. We still only have 4 taps that work. But we're getting closer. The control board works, and you haven't seen that yet. So control board's there. That's working. So right now we have it in voltage mode. That's constant current mode. We're going to go wide open here. The typical comparator circuit compares the incoming voltage to the feedback, the set point to the feedback. And I'm probably going to change that out for the VU meter chip, because we'll just get the one with the linear spacing. One of the issues with this power supply, the alignment, is that the harder you ask it to work, the closer these gaps have to be. So if you're not asking it to work really hard, then you can adjust it for like a 4 volt, 4, 8, 12, 16. But the harder you ask it to work, those points have to be closer. So instead of 4 volts, you're looking at 3 volts or 2 volts. And that's a problem, because that means that you get less operational ranges. So depending on how hard you work, we have to set it up a particular way. So I reset it right now, just a little while ago, to bring it in closer. We're trying to get it to work on a dead short, which is asking a lot of a power supply. So I have to think about where I want to set the optimal point at. But right now, I'm going to crank up the available current here. Oh, I need more. Do I need more current? Yeah. Okay, yeah, so we're misaligned right now. So depending on your load, you have to be careful about your alignment. See, I have no controllability after 3.36. So there's a voltage that the op amp goes. The op amp will go to inside the envelope. You have a linear range, and then the op amp saturates. So as soon as you hit the 12 volts in that one range, then you've got no more operational control. Now we can unload it. And we'll have full operational control, even though I haven't touched the current control. The problem is the load it's not set up for the load right now. So again, depending on how heavy of a load we're trying to set to, it determines the operational bandwidth of the power supply. I like that. That's cute, isn't it? That's really cute. If we set the load up for 1 ohm, it shouldn't have a trouble here, I don't think. But it may have trouble with 0.5 ohm at the moment. No, it won't do 1 ohm either, even at full current. Okay, so we're misaligned. The VU meter chip will make it easier. It'll just have one control, be able to dial in gain, basically. And since this is a linear control, you know, that's fine. So we're sacrificing quite a bit here. The first one's 5, the second one's 10, so we're already into range 2 here, and we're only outputting 3.8 volts into, so let's call it 3 volts. So that means we're dropping 7 volts in the regulator. So 7 volts at 3 amps. So you can see that this kind of regulator scheme is very expensive, quote unquote expensive, on power, because you lose a lot in the control envelope. It's not really desirable if you're trying to be efficient. They're fairly quiet because they're linear, but it's very expensive on the power.